Okay, ladies and gentlemen of Algebra B, we're talking about 6.3. You're talking about exponential growth. Exponential growth is exactly what it sounds like. Things are going to get multiplied over and over and over again. So that's what exponential growth is. So now, let's take a look. Here's what you're going to have. You're going to have a starting amount, C, then you're going to have a rate of change, that's usually going to be a percentage, and then you're going to have that measured over time. But time is going to be your exponent here. C value is also going to be your y-intercept. So when you look, C is going to be 8, R is going to be 0.45, so that's going to be 8 plus 1.45, 1 plus 0.45 raised to the x. So now what I like to do is go 1 negative, then go 0, 1, 2, 3, and just kind of get an idea of what that's going to look like. So you're going to substitute each one of those in and figure out what each one's going to be. So if I put in -1, so what that's going to look like is this. This is going to be 8 times 1.45 raised to the -1. So what that's going to be is about 5.5172. Now for 0, remember, 0, my answer is just going to be what this initial amount was. So that's going to be 8. For 1, put 8 times 1.45 raised to the first. You're going to get 11.6. And likewise, so on and so forth. Make sure you're following order of operations correctly, because you've got to raise 1.45 to the second power first and then multiply it by 8. So for 2, that's going to be 16.82, and for 3, that's going to be 24.389. So now graphing, just get an idea. It doesn't have to be a perfect match. So at -1, you're going to be at -5.5-ish. 0, you're going to be at 8. 1, you're going to be at 11.6. So it's going to look something like this. So try and make sure you get 3 or 4 points each time so you get an idea what's going on. Now, C is 6, R is going to be 1/3. 1/3, for those of you guys that don't remember, as a decimal, we're going to call it 0.33. So you're going to have 6 times 1 plus 0.33 raised to the t, or raised to the x. So again, go -1, 0, 1, 2, 3, just to give you an idea of what you're looking at. And then start kind of playing fill in the blank. If you got a graphing calculator, I can show you how to do this where life gets really, really easy. So that becomes 4.51. So that becomes 1.33 raised to the -1 times 6. 0 is just going to be 6. 1 ends up being 7.98. 2 becomes 10.613. Remember, all I'm doing, following order of operations. I take 1.33 squared, then multiply it by 6. So for 3, I'm going to get 14.116. So graphing, so at -1, I'm going to be at 4.5. At 0, I'm going to be at 6. At 1, I'm going to be at 7.98, so basically at 8. At 2, I'm going to be at 10.6. So that's going to give me an idea of what my graph will look like. So in 1971, there were 294,105 females in high school sports. Since then, that number's increased to an average of 8.5% per year. Number one mistake kids are going to make is that when they convert this to a decimal, a lot of kids are going to put 0.85. Don't do that. 0.85 represents 85%. That's not what you want. You want 8.5%. So that's going to be 0.085. So write an equation to represent the number of females participating in sports since 1971. All right, so T is going to be my time. So my initial amount was 294,105, and it's going to grow at 8.5%. So 1 plus 0.085 raised to a factor of T. So 2005, how many women are participating in sports? Well, probably a lot more, I hope. 2005 minus 1971, that's going to be 34. It's 34 years have gone by. So I take 1.085 raised to the 34th, and then multiply that times 294,105. So that's going to be 4711004 So about 4,711,004. So in 2010, the city of Farmington had a population 21,087 and a growth rate of 1.9% per year. Right, an equation represents the population of Farmington since 2010. So initial starting amount C, growth rate R 1.9%, so it's going to be 21,087 times 1 plus, be careful here because it's got to be 0.019 to a factor of t. So put that together and you get 1.019. So that becomes kind of what you're going to multiply by. So what's it going to be in 2013? What's it going to be in 2017? Well, 2013, that's 3 years. 2017, that's 7 years. So I'm going to take 1.019 raised to the third times 21,087 times 21,087. So that gets me 22,311.94. So about 22,312 people. 7 years, same idea, except the 3 gets replaced by a 7. So 1.019 to the 7th times 21,087. Gonna get you 24,056.59. So about 24,000 people there. So an initial population of 750 endangered turtles triples every year. Now, triples is kind of your dead giveaway. Triples actually means you're going to multiply by 3. You're not going up by a percentage. You're literally going up by 300% each year. Well, 300% as a decimal is just 3. So that becomes my amount. So I take 750 times 3, not 1 plus 3, 3 raised to the x. So 750 times 3 to the x, well, x equals 8. So 3 raised to the 8th power times 750. In a couple of short 8 years, we're going to become trampled by turtles because we're going to have 4,920,750 of them. So that's all you do there. Those who come talk to me with questions, if you got a graphing calculator, want to see how to do it on a graphing calculator, come talk to me. It will make your life easier. Have a good day.